Hey guys, so this video is all about the periodic table and it's going to give you a little bit of an introduction to the periodic table. Dmitry Mendeleev was a Russian chemist in the late 1800s, and the story goes that he developed cards for every single element and he wrote down all of their different properties. And then one night, while he was asleep in his bed, apparently he had a dream about how these cards of these elements should be arranged. He immediately woke up, jumped out of bed, wrote them down, and then upon looking back on them and reviewing them, he only had to correct the placement of one different element. So the story goes that he developed his periodic table in a dream. Now, whether that's true or not, I don't know, but it was absolutely brilliant. His placement of the elements on his table revealed a link between their atomic structure, so like how they're arranged, and their properties. And his periodic table, when he started to group these things, he noticed that there were repeating patterns in his rows and in his columns, so his groups up and down, he noticed very, very, very similar characteristics. He was not the only scientist to start organizing these elements, but he was able to offer the best explanation for how their properties were related to the location on his table. And part of the reason why we use his version of the periodic table today was because he actually accounted for elements that hadn't been discovered yet. So when he arranged all of these cards and arranged all of these elements, he left gaps in his periodic table, and he said, hey, there should be an element here and it's going to have the atomic mass between this and here's its properties. And we found 8 different elements that would fit in the gaps that he left. For example, germanium, gallium, and scandium. He was able to properly predict their properties and their masses even though they hadn't been discovered yet. Mendeleev did arrange his elements into rows in order of increasing mass because he didn't know about the atomic number at the time that he was organizing his cards. And he called his chart the periodic table. And then years later, around 1913 or so, Henry Moseley's work led to the periodic table to be reorganized by atomic number, which is the number of protons, rather than atomic weight. Now, there isn't much difference, but that did switch a few of the elements on the periodic table. Moseley's periodic table also included the noble gases that had not been discovered during Mendeleev's lifetime because the noble gases are completely inert. So let's talk about how the periodic table is arranged. So as you can see, there's a lot of yellow, which means most of the periodic table is metals. And then the non-metals tend to be over here in pink. So as you can see, as you're going from left to right on the periodic table, the elements become less metallic and more non-metallic in nature. So some properties of metals are that they're shiny, they're bendable, and they're really good conductors of heat and electricity. That's why we use them and shape them into things like screws, and why we use them for frying pans is because they can conduct heat very well. Non-metals tend to be gases at room temperature. They don't conduct heat and electricity, and they tend to hang out on the right side of the periodic table. Our metalloids have some properties of both metals and some of nonmetals. The most common one would be silicon. So here's an example of pure silicon. And then you probably know what this is. This chip is in almost all of your electronics, and it's made of silicon. There are different sections on the periodic table. So we call the things in pink the representative elements, and that's primarily what we are going to be looking at in this class. And that has to do with the valence electrons that these elements have. The transition metals don't tend to follow the same patterns as the things in pink. And then we also have these intertransition metals, or sometimes called rare earth metals, down there at the bottom. Now, these rare earth metals, these lanthanides and actinides, should actually be part of rows 6 and 7. But if we were to put them in there like this, do you see how wide our periodic table would be? That's just not convenient. And so we put them down at the bottom so we kind of take them out. But just understand that the lanthanides and actinides are really part of rows 6 and 7. Now, there are a couple other terms that we need you to know. So a period is a row, so it goes from left to right on the periodic table, and then there are a total of 7 different periods. And then groups are also called families, and these are located up and down on the periodic table.